Hi and welcome. My name is Sjoerd, and together with Michael Martin and with support from Yann, Betros, Farenheit, we conducted a research called Exploring the Environmental and Social Performance of a New Value Chain for Valorizing Waste Wool in Outdoor Garments. And in this research, we assessed the environmental and social performance of a wool sweater using EcoInvent and the PSILCA database for social lifecycle assessment for 4 different supply chains. Before doing some actual modeling, we did a little bit of literature research, and we found some social LCAs focusing on the clothing industry, specifically the social LCA by Zamani, which focuses on clothing produced in China, and one by Anderson, which focuses on fabric that is produced in China. Both of these are done in the social hotspot database and not in PSILCA. And another challenge was that our supply chain is actually not a conventional one because we use a waste flow wool. The wool used in producing these sweaters comes from sheep that are not bred for their wool, and so normally these farmers have to pay to get rid of this waste flow. And Roik attempted quite successfully to turn this waste flow into a new product. And because of this, the wool is considered to be burden-free for the ELCA, but it is included in the social life cycle assessment. Before continuing, I would like to talk a little bit more about the PSILCA database. The PSILCA database is similarly to the social hotspot database based on input-output tables. For PSILCA, this is EORA specifically, and it has 15,000 sectors covering 189 regions. And the benefit of having input-output tables as the foundation of your database is that you have this deep interconnected network, and therefore you can see where a particular sector imports from and see secondary and tertiary results of having a particular sector in your model. A big difference between environmental LCAs and social LCAs while using the PSILCA database is that the PSILCA database uses monetary values because it is based on this input-output table system. The characterization that is included with the PSILCA database has 49 indicators, and the results are shown in medium risk hours. And these medium risk hours quantify the risk associated with products along their life cycle. For the methods of the ELCA, we used, as mentioned earlier, the EcoInvent data based on the ILCD midpoint H 2016. We included 5 indicators: greenhouse gas emissions, acidification, freshwater eutrophication, resource depletion, covering minerals, fossil fuels, renewables, and then also resource depletion for water. And in the system boundaries, you can see that the sheep farming is actually excluded from the ELCA and included into the SLCA because, as we mentioned earlier, they are considered a waste in the ELCA, but given the fact that these sheep still have to be bred, we included them in the social LCA, which we're going to talk about now. Regarding the social LCA, we are using the PSILCA database, as we mentioned, looking at the social impacts. We use the weighting method that actually comes with the PSILCA database. We modeled everything in OpenLCA, Excel, and Python because the data that PSILCA outputs tends to become pretty large. We have 5 indicators, and they are corruption and bribery, child labor, forced labor, social responsibility, and safety measures. The supply chains included in the ELCA and SLCA differ a little bit. The first 3 are included in both. This is the Swedish, Belgian, and the Australian supply chains. The Swedish one focuses on wool from Sweden, scoring in Sweden. The Belgian one is wool from Sweden, but scoring in Belgium. And the Australian one has both the wool and the scoring from Australia. Now, the Uruguayan supply chain is only included in the social LCA, and it is the same as the Australian, wool and scoring happening in Uruguay, the rest in Eastern Europe. The other 3 are sensitivity analysis scenarios for the ELCA. The first 2 focusing on the energy mix changes, where there would be only Swedish energy mixes instead of energy mixes depending on the country of the activity. And the last one is a sensitivity analysis scenario where we include the upstream processes that happen to the wool if it were to not be burden-free. Now, the results of the ELCA show that this is specifically for greenhouse gases. The Swedish and the Swedish-Belgian supply chains are very close together. The Swedish-Belgian is a little bit smaller. Both show to be quite susceptible to the type of energy mix that is used, as is shown by the SenseL supply chains. And for the Swedish supply chain, including the upstream processes from the wool production, also almost doubles the amount of greenhouse gases released. Now, the Australian supply chain shows to be the largest when it comes to impacts, and this is mostly due to the increased amount of transport that is necessary, and the energy or the CO2 that is offset by the lanolin production, which is shown in the Belgian and Australian supply chains, have little effect on the overall result. Now, also showing the results in the table for all the indicators shows that the Belgian supply chain performs slightly better in most of them, but significantly worse in the resource depletion for water indicator. And this is the trade-off that you would make when it comes to the Swedish or the Swedish-Belgium supply chain. Concluding for the ELCA, valorizing wool has a significant potential to reduce environmental impacts. The impacts are very process dependent, and the electricity system employed is also very important for the overall result. Now, the value of wool, whether it's considered to be burden-free or not, also has a significant influence on the total result, and compared to linear options, the valorization options are better. However, it must also be said that the Australian supply chain is based on a merino wool and not on a new wool, and therefore the two products don't have the exact same function. This table shows the results of the social LCA for each supply chain in all of the 5 categories. And you can see that the Swedish supply chain performs best for 4 out of the 5 categories that we checked. There's also a large difference between the European and the non-European supply chains, where the non-European supply chains perform significantly worse in 4 out of the 5 categories that we tested. For the Australian supply chain, it mostly is the case for child labor, whereas for the Uruguayan supply chain, it's more about the goods produced by forced labor and social responsibility across the supply chain, where it performs worse. Plotting the results from the table prior as performance as a percentage of the highest per indicator, you see that the forced labor shows the largest differences between the supply chains, where the Uruguayan supply chain performs worst. Safety measures is the only indicator where European supply chain performs worst, which is the Belgian supply chain. And last, you also see that the corruption and bribery is the largest in Australia, which is interesting because it is generally considered to be part of the Western world. And so, corruption and bribery should be less of a thing. Taking a closer look at the forced labor results for the social LCA shows that plotting the results, both absolute and in normalized terms, there is a big influence from other industries happening for all supply chains that are not necessarily associated to the supply chains. So for the Uruguayan supply chain, it's the most logical one because the largest influence comes from Argentina. So the most risk of forced labor comes from Argentina, but since they share a border, these interconnectedness is to be expected. However, for the European supply chains, the Swedish and the Swedish-Belgian supply chains, you still see that over 50% of the risk associated with forced labor there is from China and India combined. And for the Swedish-Belgian one, it is over 60% of the risk that originates from either India or China. And for Australia, it is the starkest difference, where 75% alone of the risk originates from China. And this is an interesting view on whether your supply chain is connected directly or not with these particular countries that have less protection for their laborers, still have such a big impact on the supply chain in the end because of secondary and tertiary effects. Quickly going through the sensitivity analysis of the social life cycle assessment, the scoring process in the Australian supply chain showed to be responsible for the big influence of the Chinese economy in forced labor. 15 cents out of each dollar spent on the scoring in the scoring sector was directly connected to the manufacture of wearing apparel in China sector. Also, the land transport industry showed to have a significant effect on corruption and bribery, and 65% of the Belgian effects and 81% of the Dutch effects of the land transport sector in both of those countries are directly stemming from the activity itself, meaning that they are the source and not the connections that they have to other sectors. Last, a deeper dive into where exactly the effects of forced labor, child labor, and social responsibility stem from. We took a little deeper dive into the wool and scoring processes, and it shows that wool and scoring have a lot of effects on the forced labor, especially in Uruguay, and for a larger extent the Australian supply chain when it comes to child labor, and for social responsibility, again, the Uruguayan supply chain that showed to have a big effect on the overall result. Discussing some assumptions that have affected the results maybe is the deriving the land transport costs from cost retrieved from ROIC, which we sort of backtracked and calculated cost for from a $1 per kilogram-kilometer perspective. And deriving the transport costs from worldfreightrates.com might also not have been the greatest idea because they didn't show up at all. Lack of disaggregation in smaller industries reduces the precision of the activities available and introduces noise. And even though this happened, similar results emerge from the other literature that we already discussed in the start of this presentation. Concluding, the European supply chains perform better overall. Largest differences are in child labor and forced labor. Main sources of risk are China, India, and Argentina. And for the IO nature, this allows for interesting indirect impacts, but on the other hand, the generalized data is not always representative. And the conclusion being that European standards are high when it comes to social impacts. And these standards result in a lower risk of social issues for European produced goods relative to non-European produced goods. That was our presentation. Thank you very much. If any questions, we try to answer them now.